All right.
We're working here at
All right, folks. Let's get started. So we're very excited. So welcome to the last day of Code Astro. Yeah. We're very excited. So we're very excited to have a panel, industry panel for you first before we go and do group presentations and things like that. So this is just an opportunity for all you all to ask questions. If you had any questions or curiosities or interests, like what is it like on the other side? How do you transition? Things like that. Any and all questions. But before we get started, maybe our panel can introduce themselves briefly. Who they are, what their industry experience was. Just a little bit like how they got there from where they started out in academia.
Hi, I'm Sarah. Nice to meet all of you. So I did an internship at Google while I was in grad school. This was between my third and fourth year of grad school. The motivation for that was that I sort of felt like I wanted a backup plan, and I didn't really know all of the options that I know about in academia nowadays. And I asked Jason what I should do, and he's like, well, maybe you should think about applying to a tech internship. And so I did that, and I got some experience, and it was very helpful. And I think even if I do end up staying in academia, I think it will end up being helpful because I will inevitably mentor students who want to go into industry. So I'm very happy I have that experience.
Hi, I'm Candace Stocker. I am a former attendee of Code Astro. I think I did this in the summer of 2022, and it was awesome. And currently I'm the data analytics lead for the city of Chicago, so I help all the rest of the departments in the city do data science and data analytics. I also started a small nonprofit that helps other small nonprofits do data science and data analytics work. So if any of you are thinking about starting a nonprofit and know all about that process, hit me up. But I also worked as a data scientist for like a finance real estate company while I was in grad school. And then I finished my PhD here at Northwestern in physics and astronomy back in 2023 too. So I kind of went through the whole Astro PhD to data science pipeline.
Good morning, everyone. I'm Saeed. I got my PhD at University of California, Riverside in astronomy back in 2023. And I have an internship in astro technology, and I worked briefly in a trading company. And so I faced a lot of challenges transitioning from academia to industry. And as I was discussing with them, when I looked at the material in this workshop, I felt that all of it was very, very relevant. And because I saw that there were a lot of challenges that I felt that I solved if I joined this workshop, if I knew it during my PhD. I was working with scattered Jupyter notebooks, and during the first years of my PhD, if I knew about these good practices, it could have saved a lot of my times and made my research much more efficient. So I volunteered to be here and share my experience with you.
Awesome. And I'll be mostly moderating the panel. I did a software internship 13 years ago, so anything I say is totally out of date now. So I'm just here to ask questions. Just before we start, it looks like we have a few mic issues. I'm going to try switching microphones. 1 second. Okay. It might be that we'll switch with this mic. We'll switch one. Well, no, we'll have you guys use this mic because I think this one is louder for some reason. Okay. All right. Okay, we're still using this computer. think. Sorry. You got it? Okay. Sorry about that. We're trying to figure out audio issues. Okay. Does anyone have any questions to start off? Yes, we have one here.
Thank you. It's very nice meeting all of you. I think I hear a lot about how industry is very good, well, of course in terms of money, but also in terms of work-life balance and a lot of stuff like that. But I'm curious about what would you say are some of the downsides of industry? Like, what would you like it to be different?
So it really depends on the type of industry that you're going to. If you're asking about work-life balance, I do have good experience and bad experience. For example, trading companies are notoriously bad in terms of work-life balance, especially if you're working in high-frequency trading. The environment could be stressful. So before you decide to go into an industry, make sure that you do all the researches. You don't want to end up working 16 hours a day and being in a stressful environment such as trading if you're not ready for it. I'm not saying all of the companies are like that, but before you make a decision to accept an offer, you can go to the Glassdoor, you can go read Reddit and ask previous people who work in the company and ask them if it's important for you, if work-life balance is important for you, and ask them if that company is specifically good in terms of work-life balance.
Yeah, I definitely agree with that. I think it depends on, as far as work-life balance, it depends on like what kind of industry. I think, if you know how in astronomy, everything that's not hydrogen or helium is a metal, I think similarly, everything in like academia that isn't academia is industry, but like, it's different between like if you're in like a finance company or like I work in government, I wouldn't really consider that industry, or for a nonprofit. Like in government, yeah, there's great work-life balance. I mean, for the most part, I work like 40 hours a week. Some weeks are like more, but the downside, I think, in government for me particularly is I work with, I know, a lot of like really brilliant, smart people, but you know, about half the people I work with who don't really have like a background, they have more of a background in like policy than like technology, so, or data science or analytics. So it's cool because sometimes I feel like I'm the person in the room that knows the most about what I'm doing, but it's challenging also because sometimes I'm, you know, the person in the room that knows most about what I'm doing. It would be nice sometimes if there were more people, you know, around me who could help upskill me, I guess, in the things that I want to know more about, if that makes sense.
And I think, first of all, I want to say that my answer to these questions changes every year. And if you go back and watch old Code Astros, you can see we have like totally different opinions about things. But I think two things that are maybe worth saying. My partner also works at a big tech company, and so I've seen his career progress like alongside my own in the last couple of years. And I think the main thing that he's been frustrated is that he doesn't have a lot of intellectual freedom in what he's doing. So he really likes what he's doing, but he feels like he doesn't really have the ability to say, I don't really want to do that, or like go in a completely different direction. That said, he just changed teams like last week, so I don't know, come to next year's Astro and find out how he's doing that. But that is one thing that I have really liked about being a postdoc, is that I feel like I really get to set my own research direction, and I'm figuring out which questions, and I can pivot relatively easily too. So I think for me, those are some of the main upsides and downsides, but I would totally agree with Candace that like there are, so many different types of things. They're both distributions and in industry and academia, and we definitely know that there are some labs in academia where work-life balance is great and somewhere it's terrible. And so it's a lot more about who you work with, I think.
Hi, I have two questions. The sort of first one is, we hear a lot about people making the transition between academia and industry and varying levels of reasoning behind that or motivation behind that. I was just wondering if you guys could share some of your sort of reasons why you thought that switch was the right one for you, or why you made those decisions at the times of your lives and careers you did, and if you could also say maybe one thing about making that transition that you weren't expecting, something that surprised you about making the transition, because I know a lot of people are unsure about it, and maybe something that they wouldn't necessarily be expecting upon making that sort of switch.
So my personal motivation to actually go to industry was genuinely, it was money. I mean, I really wanted to work in a job that gives me a lot of money, and that was one of the biggest motivation that I had. Then working with that lifestyle and working in an industry, I realized that there are a lot of other things that I need to consider. For example, it doesn't matter how much money I get in that job, if I don't enjoy it, I would rather be back in academia. One of the other reasons that I got back in academia was the actual intellectual freedom, because when I was working in trading company, I was basically doing a simple task repeatedly, and it wasn't mentally stimulus for me. So that's why I realized that I need to find a trade-off between money and what makes me enjoy my life every day. Because imagine working like 12 hours a day, or depending on the job that you have, 8 hours or 12 hours, and you don't enjoy it. So.
When I remember my first year of grad school, there was a career panel a lot like this one, and I remember asking like one of the panelists, this was before my prefrontal cortex was fully developed, and I said, so like, why did you sell out? So it's kind of cool that it's all come back full circle. There's two answers. The first answer, and they're both true, but one is the one that I tell people and one is the one that I don't. And the answer is that I tell people is that I love astronomy, I love science, but I wanted to do work that like had more of a direct impact in people's lives, like social impact, and to feel like I'm contributing like more directly, I guess, to things. And that's partially true, but the other part of the answer is like academia was very stressful for me. My particular experience, I think, was like exceptionally difficult and weird. But also like I just found it to be really, really stressful. Not a lot of work-life balance and for not enough money. Like if I'm gonna do something, for me, if I was gonna do something that was that hard and like brought me that much turbulence, like I better be getting paid a lot for it, and I wasn't. So that I guess is the deeper answer. But to that point, I think like I really worried about in grad school, like, I don't want to sell out, like I want to be an astronomer, this is what I set out to do. And I think like if you want to do astronomy and if you want to stay in academia, you can do it. I just didn't want it enough. Like I didn't like it enough to give up, the work-life balance and the money, I guess.
I guess one thing I can add about something that surprised me is that the time scale of projects was a lot faster. And the internship that I did was called a research internship. So I was supposed to be working on open-ended problems within Google search. And I was sort of shocked that they were like, oh yeah, an open-ended problem. So like 3 months, right? And so it was like very, very different. Even like the longest time scale was like very significantly different than the longest time scale in academia. I think in terms of motivation, I think like anyone who's sort of a like middle year grad student probably knows this experience of like feeling very existentially uncertain and not sure if you could like become a professor and thinking that that's sort of the only way to be an academic. And then if you get to that point in the thinking, you're like, well, why am I doing my PhD program at all if I don't want to like continue down this academic path? And I think I also just didn't feel like, people always sort of said, oh yeah, you can go into industry, but I was like, okay, but how? Like, what do I actually need to do? What are the steps? What does that look like? Like, I wanted to make an informed decision. And so doing an internship was my way of understanding the application process, actually going through technical interviews and like proving to myself that I could do that, and then seeing what it was like and deciding if this was something that I actually like could imagine myself doing.
Several questions in the queue.
Hi. So I was wondering, because Sarah said that she didn't know about all of the opportunities that you had in academia to be a scientific software developer, I guess. So I was wondering a little bit about that and how is it. And I guess you already kind of answered, because I also had the question if there are jobs like that in industry. So yeah.
Yeah, that's a great question. I think I have a lot of answers to that. One is that scientific software development is being valued more in our community, but it's definitely still not enough, and it's not to the extent that science really needs. But I do think the trend is up, and I think there are several places where you can apply for jobs that are explicitly like software developer for science. So like at the Flatiron, at the Center for Computational Astrophysics, you can do that. There are jobs at like places like IPAC. There are jobs at national labs. There are jobs at I was gonna say something else. I think they're also like so if you are a grad student, if you're getting a PhD, you're at an R1 or R2 institution, but those are not the only types of institutions. And there's lots of different ways. If you really like teaching, you really like astronomy, you can go to a small liberal arts college, you can go to a community college. Not to say that those jobs are easy to get, but there are just more options that you can consider. So I think I had this single idea of success of like, be a professor at an R1, and I'm also, for the record, I'm still not like sure what I want to do. Like, I think about it less like, binary industry or academia, and more like I'm going to apply to several different things and take the best option that is available to me. And I think I feel really lucky and privileged that I have the experience to be able to do that and make that decision, but that's partially why I want to be well aware of that path.
We can keep going. I'm gonna try to alternate some Zoom questions. So one of them was kind of related. What sort of jobs are available in the market given the skills we gain in the PhD? Which jobs should we be considering given the factor of money, work-life balance, and enjoying the work? I guess your personal opinions.
So in terms of the job titles that you can apply for with a PhD in astronomy, there is data scientist, research scientist, and quantitative researcher, quantitative trader that they require a lot of the skills that we have working with data, skills in Python, SQL, and understanding machine learning and deep learning. And I could say these are the job titles that you can apply for. But what was the second part of the question?
Which ones you think you should, that they should apply for, given factors such as money, work-life balance, and enjoying their work? I guess this is your own kind of editorial experience.
It's really like, you need to, I think it's different for everyone. So for example, I prefer to have a good work-life balance even if the salary is lower, now that I have the experience. So before you accept an offer, you need to research the company, ask the people who work there, go to Glassdoor. There are a lot of websites like Glassdoor that you can take a look at their work-life balance. There are reviews of thousands of people, and there are thousands of companies out there. So you should do your research definitely before you accept an offer, and then depending on what you want, you can then make an informed decision.
Yeah, I agree with all of that. I think, yeah, it depends on like your skill set and what you did in grad school too. I was talking to a student the other week because there's a lot of like talk about data science and astronomy, or that was like my experience. And so she came to me like inquiring about a job with the city in data science. But when she told me about her background, I was like, oh, like you have more skills in software engineering. Like, so I think it just, yeah, depends on what you're doing research-wise. But usually, yeah, everything you said, data science, analytics, software engineering, trading.
And I think the one thing that I would add is that there are like different like books that you can use to prepare for different types of interviews. And so like there's a really famous book that everybody will tell you to get if you're trying to do software development or software engineering, which is called Cracking the Coding Interview. There's an analogous one called Cracking the Data Science Interview. So data science is more like working with data, understanding data, making recommendations based on data. Software development is more writing code, building code. I think the most common thing that I see talking to astronomers and academics who want to go into industry and is not that they don't have enough experience, but that they don't know how to present their experience. So like if you have worked with Git and GitHub, if you have data visualization skills, if you know Python and SQL, like all of those things are really valuable in industry. Even knowing VS Code, like VS Code is a thing that people write on their resumes. Yeah, and also in general, I'll say if any of you want like specific advice about like your resume, you should feel free to reach out to me. I don't want to speak on behalf of everyone, but
One more thing that I want to add in terms of preparation, there are 3 types of interviews. It's coding interview, a case study interview, and testing your theoretical knowledge. For a code interview, what I found very helpful is a website called NeetCode, N-E-E-T code.io. Not like LeetCode, but this one is very organized, and you can basically learn all the coding, like arrays and hashing, like everything is very organized. For SQL, you can go ahead and practice in SQLZoo.net. There are a lot of interactive practices. And for case study, you can go ahead and look up all the guided projects in the web. Like there are a lot of courses in Udemy and Coursera that if you do a lot of guided projects that are in multiple industries, then you would understand how people in industry, what are the projects, the specific projects that are in different industries. And that really helped me to prepare for the case study part of the interviews.
So something that I found out recently is the university where I'll be doing my PhD seems like it has some sort of built-in pathway to let the PhD students spend up to a year working, like take time off and work in industry. And I don't know how common that is for people, but if that kind of opportunity presents itself, is that something you recommend someone take even if they're considering a career in academia? And how do you find opportunities? Like how do you identify the sort of job you would do with that time?
I definitely would, because I did like a data science fellowship when I was in grad school before I thought I would go into data science. And then like that ended up being really useful. So, you know, it's always good to have a lot of experiences under your belt, I think.
How did you find that opportunity?
Oh, I think the university, yeah, it was like through the university, but that's a good question, like how to find those opportunities. And this is like, I guess, an annoying answer, like networking, yeah.
You can network here.
Yeah, LinkedIn also.
We have some people to network with.
I was gonna say, do you have something in mind, Jason?
Sorry.
No, just LinkedIn. LinkedIn is how I found my job.
Okay, I want to do one more from the remote, and then we'll keep going with the in-person. They were wondering if you have any resources to recommend, so such as maybe professional groups, meetups, any other groups that you found helpful in your own career trajectory before and now.
So cracking the coding interview was very helpful for me. It's through PDF online. Beyond that, I think the thing that was most helpful was actually practicing technical interview questions with another human. It's totally different to know the answer to a question and be able to like write code for it on the spot. Many of you have probably taken like qualifying exams or oral exams, and you know this all too well. The best version of this is someone else who's preparing, so they actually like have some familiarity with the material, but even like doing it, just saying it out loud or like practicing with another human is miles better than just like coding silently on your laptop.
There's a lot of things, but one tool that has been more helpful to me than anything else, surprisingly, was Northwestern's alumni network. I met like one of the best mentors I've ever had through the alumni network, and he like helped me get a job interview, he helped me with my nonprofit. So like again, networking, but yeah, the alumni network in particular, or LinkedIn, and like finding people who like graduated, who are doing what you want to do and like went to the school you went to like help you learn or mentor or get those skills.
Yeah, I mean, exactly the same. I had career fairs at my school really helped me. Also, KDD, Knowledge in Data Science and Data Mining conferences. They also have a lot of career fair and job fair. There are a lot of other conferences that you can attend and submit your resume and go there and network with people. In terms of, also I have done a lot of mock interviews with my friends who are currently working in industry. The other thing is, it's very important that for the theoretical knowledge interview, you fundamentally know what's going on when you're trying to answer the question in the interview. You need to show the confidence, right? You need to know that, you need to show them that you know fundamentally what's going on in like data science and machine learning, because you all passed E&M, quantum mechanics, statistical mechanics. It's not going to be more difficult than that, you know. It could be scary, but you all can reach it definitely. For example, knowing how linear regression works fundamentally, trying to write down the equations in linear regression, write down loss function, how to approach like what is gradient descent, you know, what are the equations, because if you know the equations, if you can write it down, then you can answer to all the questions, like how you can add regularization to loss functions, and then when you're doing a gradient descent and you have regularization, how all of these equations will change. So make sure you fundamentally know all of this stuff before you go and take an interview.
I'm just going to jump in here, and I also recommend cold emailing other astronomers that have transitioned to data science. They're surprisingly amenable to helping other astronomers, even if they don't know you. It's like someone you know of someone you know. Those kind of people are very helpful.
Hi. So I have a couple of questions added into one. So I was talking to a friend who had transitioned once into industry before and then back to academia. And then what I learned from like many other people is that the landscape is constantly changing, right? So maybe 5 years ago it was like if you want to do a data science job after astrophysics, you can get it. But now I did like a very cursory look, and it seems like all the companies and all, they're wanting like a combined package, right? Like not just data science, you want to do full stack or whatever. Like and it does get overwhelming because most of the times they're using nomenclature that we're not familiar with being a PhD students. And now I realize that the universities will have like very condensed bachelor programs or master's programs, which is focusing only on this, what the big tech company is looking for, right? So, like compared to that, like from a fresh graduate in this particular field that all the companies are looking for, and then us as astrophysics PhD students who are specialized in a very specific way of coding, right? We are using Python, we're making packages, we are doing data analysis, and how do we not compete, but how do we find a path through that? Because what if I want to do data science, machine learning with an impact in the world, even through an industry company, but I don't want to do like AI project manager. I don't even know what that really means. So how do I, like everyone in India seems to be doing it, but I don't know what it means. So I don't, I just know the AI part of product manager. What product? What kind of work is that? How do we fit in there? So if you can answer that.
So I hear a lot of anxiety and I understand it.
The mid PhD crisis that you talked about.
Yeah, totally understand that. I think a couple things. One, the market is much worse than it was a couple years ago. That's unavoidable, and I don't think it's worth like trying to pretend that that's not the case. I think it's sort of dire everywhere. Like I think it's also harder in academia. There's just not a lot of jobs right now. That said, I don't think the fundamental stuff that you need to know in order to apply for one of these jobs is going to change anytime soon. Like the stuff in cracking the coding interview and cracking the data science interview, like that stuff is always going to be like, maybe not always, but right now it is still the core stuff that you need to know to do those interviews. And it sounds really, really hard until you start doing it. And I think also don't undersell the experience that you have so far. Like you, as an astronomer, you have really unique experience working with data. One really interesting thing that I found in industry is that nobody knows anything about environment management. So like they don't know how to like make a content environment because it's all like set up for them, at least in the big tech companies. So like there are sort of secret things that you know that you don't realize you know are important. So I think the way that you like leverage that is you talk to people who have both industry and academia experience and people who know about the transition and figure out how to present yourself in the best way possible. And then I think you also just have to start trying. Like people always talk about this concept of burner interviews. Like your first interview is like not going to be good. But you need to start and like you do that first one and you practice and it's horrible and you cry afterward, but then you like keep going and you do the next one. And like just getting into the like application process is very helpful. Another like thing that I thought about when I was applying for internships was that I was like, it's okay if I don't get an internship. Like the whole time I was like, I just want to know about the process. I want to get experience with this so that if when I'm graduating from my PhD, like decide that this is the path I want to go down and not starting from zero. So I think that was also really like healthy for me because it meant that it wasn't going to be a pass-fail experience. And also thinking about it in the context of an internship was really nice because it was like, oh, worst case scenario, I just keep doing research this summer. Like it didn't feel like all or nothing type situation. I don't know if that helps, but you can do it.
I'll just add one thing, and hopefully this will be helpful. I think it would be worth your while, I think, to look, like a lot of these jobs, a lot of the people who post these jobs have no idea what they're talking about. And they're like
they won't accept your application because you don't have some like Tableau on your resume, which is this really annoying dashboard software. Like poke around Tableau a little bit, poke around like AWS, Google Cloud, that kind of stuff, so you can put it on your resume. It's not hard, none of you are gonna have a hard time like learning how to use it, but like having it on your resume or not can sometimes be the difference in, you know, your interview getting to the, or your resume getting to the interview level.
Yeah, I mean, I just want to add that I understand your anxiety. The industry became much more competitive, so we must also be more competitive, and it's a trend that I observed as well. Expand your portfolio, expand your skills. So, for example, what are you working on in terms of data science at the moment in your PhD? Machine, like what types of machine learning? Yes, so you. So, for example, you can find guided projects that are not in astronomy and put it in your GitHub, because some hiring manager look at your GitHub, right? And they see that, oh, it's your experience, for example, in machine learning is not just limited to astronomy. You have done guided projects with results, with good visualization, and you put it in your GitHub so they can see that you're capable of expanding your skill outside astronomy as well. And just, yeah, we have to try much harder. There's thousands of applicants out there, and there's like fewer basically jobs, and some of the international students definitely have a much more challenging because they need visa internship as visa sponsorship as well, and that's just, yeah, I mean this is the trend, but we have to try harder.
Hello. So I have been told by people that like once an astronomer gets out of academia and goes to the industry, like it's hard to come back, or like people don't come back, or like whatever. Like, but like I also don't know how true that is. Can you say anything about that? Like, how easy is it for someone to go from industry back into academia if they so choose?
So I know a couple people that have done this recently, like gone to industry, been there for a while and then come back. I think the main thing that helps them come back is having people in academia that like are going to advocate for them and want to help them find a job. So a lot of people, I know somebody who like started, you know, working as like a project scientist for her former PhD advisor. And so I think like the connection, like you don't need to come back into academia, but if you are leaving sort of wanting to leave the door open, like I think just like having, you know, talking to people in academia and maintaining those connections, I think are important.
Yeah, I mean, that's why I'm here. I'm hoping, you know, if I want to come back, Jason will give me it. I don't know. I don't know a lot of people that have ever wanted to go back, but I've heard it happens.
I came back and it was very easy, honestly. I mean, so right now I'm at the University of working as a project scientist at UCR, and I feel like the transition from industry now to academia was very easy. And part of it was because how supportive my community at UCR was, and it's depends on the person, but I really enjoy all the projects and all the research that I do in academia and the environment and everything. So for me, it was very easy and it was delightful.
Hello. I'm curious, Sarah, you kind of already touched on this a little bit, but what skills did you gain that helped you the most in your switch to industry and like made you feel confident even to make that switch? And then also, when you were interviewing, did people understand your skill set considering you were an astronomy PhD? Like, we do have a lot of skills, but it sometimes can be hard to articulate and explain them to people.
Yeah, no, people have no idea what a PhD is, and they, really, you have to really hold their hand through, like, this was not me being in school and taking classes for 6 years. I did projects. I can show you the projects. Here are the projects. I think I thought a lot about like how to present my experience. I think working with open source software and writing open source software was a huge thing. People assume that Orbitize was a startup, and they would ask me how long I've been the lead developer of this new startup Orbitize, which was really funny. But yeah, I mean, presenting it that way, like they don't care what classes you took. Not really. They don't care what classes you took. They don't care like what your PhD research is about. Like they want skills. So if you say like, I worked on an X-line open source software package, I built it from scratch, or I contributed new functionality to an existing thing, like I, give it in terms of like things that you did, like deliverables, rather than like, I went to this university and I studied supernovae, blah, 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 blah. Yeah, I was gonna say something else, but I forgot.
Yeah, I think deliverables, focus on deliverables. I also think like, doing projects, that are outside of your scope of research that you can put in your portfolio. Like, if you're building a bunch of regression models, work on a project where you can do something with computer vision or NLP or something like that you can put on your resume. I'll also say, I think that getting the first job out of grad school is like the hardest. After that, after you have like the experience on your resume, it's something outside of academia, it becomes like a lot easier. So it seems hard at first, but it gets better.
And so, in most cases, your first interview is with a hiring manager, and the first question that they ask you is briefly discuss what you have done in your PhD, in your academic research. I try to organize my answer in a way that they understand. For example, I told them what is the question that I was trying to answer. Then I told them what types of data I was working with, imaging and spectroscopy. I told them what are the techniques that I use. For example, I use like a machine learning techniques, transformers, or linear regression, as simple as that. And then what was the result and what was the challenging part of the project. So I prepare all of those before interviews and practice, so I can basically show confidence during the interview. And I feel like when you show that to them, it's going to have a positive impact.
Okay, great. Thank you, Jason, for running around. And also thank you so far for all of your questions. This has been very helpful. I have a question about soft skills a little bit. So you're talking a lot about hard skills, and I wonder what role soft skills like presenting or writing, collaboration, etc. has in kind of helping you sort of make your application unique, or in, I guess, just generally helping you find jobs, especially if it's not in your area, or if you're working like in a nonprofit or government, for example.
Yeah, that's a really good question. I think my experience, so the way that the Google application process worked was that I had an initial like phone screening with a recruiter. Recruiters are generally not like technical experts, so it's just basically they're making sure that you like have a pulse and you're not like a horrible human being. So I felt like there was maybe a little bit of soft skill in that, just like being like, hey, nice to meet you. Being like charismatic a little bit. In the actual like technical interviews, I felt like it was very like down to business, like it was a 45-minute thing, start to finish. I got on and they were like, okay, here's your question, like start typing in Google Docs. So I felt like it was very much about, but that said, I think maybe one, I don't know if this is sort of like a firm skill. I thought that was a hilarious joke. Like the firm skill was like being able to articulate what you were thinking, which is something that really doesn't come naturally to me. I want to like take a problem and like go like a little squirrel and like work on it by myself, and then only like come back when I have like fully thought out the whole thing. I can present it. So it was really hard to learn to like talk through what I was thinking and not be sure what the answer was and just sort of like verbalize that. So I think that was probably the most important firm skill for the technical interviews. I think so I did 2 technical interviews, and the last step of the process was a project matching interview. So once I passed the technical interviews, I had an interview with the person who was going to be my manager, and that was like I wasn't quite as much of a like code this thing. He was just sort of like, here's the general description of the problem I think you're going to work on, like in broad strokes, how would you solve it? And so that was, I got to like show off some like things that I knew and like give some ideas and techniques that I might be able to apply. I think there were a ton of soft skills involved in like doing the job. So like, in general, things that make you work well as a team, work well on a team, I think are going to be very helpful in making you have a good experience and making people like you and be successful. Yeah, I don't know if that answered your question, but.
Yeah, I agree with all of that. Soft skills, in my experience, have been way more important outside of academia than they were inside. Like one example I can think of is like during my PhD, I feel like people would give these research presentations, and it was like almost like the more confused people were, the better it was, or like the more impressive the person talking was, and like you can't get away with that kind of stuff. And at least in my experience in my work, like you have to be really good at like explaining, in my case, like these advanced concepts of statistics to people who had never taken a statistics class. And yeah, I think and again, because like I work with a lot of people, and even the people that were hiring me didn't really know what I did. The second thing kind of related to like soft skills is like and I just want to make sure this comes up, like I feel like my experience like as a woman going in again to like, I know this is just kind of this perfunctory thing, and we talk about this all the time, but if you're a woman, if you're a Black woman, if you're whatever marginalized group, like it's just gonna be harder. And if it's not harder, you're gonna feel like it's harder, you're gonna feel like people are judging you. And so I think just getting good at like learning how to be in those situations and going into a place, like the soft skill of like going into a room with a bunch of tech bros and like finding a way to relate to them and make them like you. Like, people tend to hire people who they like and who are more like them, and so you have to like kind of, I think, in my experience, like learn how to like socially engineer the situation a little bit.
Yeah, all the points she said is very, very valid and supported by all the data in tech, and that's kind of some of it is very unfortunate. But to be more specific about your question, soft skills, I remember I had one interview. They gave me a Jupyter notebook with simulated data, and they wanted me to design a predictive model and an evaluation pipeline. I feel like because I had the PhD, I had the advantage because we publish papers, we know how to start, organize, and sectionize our research, So I remember that I put a lot of markdowns, organized the Jupyter notebook into data preparation, feature engineering, model selection, and evaluation. And I put the reasons that I had for choosing, for example, why, based on this simulation of data, why did I choose S3 Boost? Because, for example, it was imbalanced data set. They gave me like 3 hours, and I found that at 2 hours and a half, like 30 minutes, I realized, oh, it was imbalanced, so I had to. But to your point, after I got the job, I talked to my manager, and they mentioned that we hired you because of that, because I was able, I think this is, if you mean soft skills by that, I think part of it is that, yes, because of whatever we are doing in our PhD, I think we have the advantage with those soft skills, and I think those are really, really important.
We have like 5 minutes left, so I'm gonna try to squeeze in like 2 questions.
I just want to add one really quick thing, which is that I feel like I've learned that people treat you the way you present yourself, and so it's really important to be confident and not diminish yourself, and that really goes a long way.
Hi. So this has already been talked about a little bit already, but I was kind of wondering, like, if you have any more advice on how to get your like foot in the door, like for example, red flags for resumes, like what are things that maybe you put in a CV that would like not do well in a resume, just stuff like that.
Yeah, totally. I think the best way is to talk to somebody who has experience. You can contact us, we'll be happy to help you. The very short summary is that resumes are much shorter. Your resume should be 1 page. You should have no publications on it. You should have only skills. You shouldn't have like, I went to this school, then this school, then this school. Like maybe put 1 school, but then put skills and deliverables and projects rather than like academic appointments. It should also look nice. Like having a well-formatted resume is a good thing.
Yes.
Yes, but I just want to add another advice. So right now, because of the job market, people tend to be more negative in terms of oh, you can't get a job, or but I'm pretty sure that it's scary, but all of you definitely can reach it. Make sure to not listen to, or make sure that those negative things do not impact you. You're doing your PhD in a very difficult area, difficult subjects. Definitely all of you are very talented, and just expand your portfolio, improve your skills, learn about, for example, if you're going to learn computer vision, make sure to fundamentally learn it, like what is classical computer vision, what are transformers, or if you want to learn time series, make sure to understand how to deal with multivariate time series, how to deal with time series in different scales like yearly, daily, or nanoseconds. Right? Some of the companies out there, especially in Chicago, like trading companies, they work in high frequency trading, which is like working in nanoseconds, like buying and selling in nanoseconds. So you're making money in nanoseconds. So make sure if you're starting something, if you're trying to learn time series, make sure to learn it fundamentally and learn everything about it, so you have the confidence when you're interviewing. And don't be scared. I'm pretty sure that all of you can reach whatever you want to do.
Last question. Okay, no pressure or anything. I actually have 2 questions. One specifically for Sarah. I wanted to ask what you did to prepare for this internship during grad school, and then the one that's more broadly for all of you is if you could go back now, like if you woke up and you were a grad student again, is there anything that you would do differently, skills that you would want to learn earlier, et cetera, et cetera.
Yeah, so I think there were some like social things I did that helped. One was that when I like did my candidacy, which was our equivalent of like proposing my thesis plan, I actually like wrote in time to prepare for interviews and then also to do the internship. It wasn't a crazy amount of time. It was like over 1 quarter, I'm gonna do 10 hours a week of interview prep, and then I'm going to take 3 months off over the summer. And I think like presenting it in that way really helps convince my like thesis committee that this wasn't gonna like take over my whole thesis. People will, it was the kind of thing that when I decided I wanted to do it, everybody except Jason told me it was a terrible idea and that I had like that there wasn't enough time in my PhD, but there absolutely was. PhDs are really long. I think doing something that wasn't my PhD in the middle of my PhD really focused me, and like it was like coming back to my work with like new eyes almost. So I absolutely would do it again, even if I never do anything else outside of academia. I'm extremely glad that I did it. I think it helped me in a lot of ways.
I think I would have connected, like during my PhD, I would have connected with more people outside of academia. Like, you know, I did some like internships and little projects things. I would have tried to do more of that, I think. And to do more projects that aligned with kind of what I wanted to do when I left school. Are we gonna have a minute for a closing statement after the questions? Or can I just make my
You can make it now.
Okay. I just want to say, if anyone wants to, I'm gonna leave my cards here. It would like make my day if you like wanted to talk to me at some point or shoot me an email and we can get on a Zoom call. If you have questions or like resume concerns, more than happy to help. It's like a part of my job. Also, like I'm hiring pretty soon, data analysts and data scientists and data engineers for our team for the city of Chicago. So if you're interested in that, yeah, let me know. I'll leave my card here.
So I would have gone to 2 or 3 internships instead of 1 internship. I would have learned how to code systematically with good practice instead of just having scattered notebooks all of mine. I would have learned how to store, how to do good practice in data storage and data management. Make sure that all my codes are on GitHub so other people and other collaborators would be able to tell, and it's better for my publicity, like I would have been able to show off during interviews instead of just, but yeah, I would focus on coding more.
I feel like if anyone else wants to make final statements before we wrap up. I have no final statement. I just like to thank our panel for giving their time out of their day and their week. All right, let's take a 5-minute break. We're always running behind the last day, but that's okay. We'll resume 8 minutes after the hour for project presentations. But in the maybe if you guys are open to being contacted, you can send out give us your email. We'll put your email in the Discord. We'll put it business cards here or something, and the folks can feel free to reach out and things like that. All right, let's take a 5-minute break and then we'll do project presentations.
Thank you so much. So fun. Yeah, it was really good. Like, it was really nice hearing all.
All right, everyone. We're gonna get started with project. Oh, thanks.
Thanks.
We're gonna get started with our project presentations. So how this is gonna work is each group can, if you can log on to Zoom and share your screen and demo the project from there, please do that. For in-person folks, please mute your computer in both the sense of muting the microphone and also turning off the sound to prevent feedback. So we're just gonna do this to be 4 minutes per group plus 1 minute transition. I'm gonna set a timer so that you'll hear something. Question? Where is the Zoom link? It is, if you scroll up in the announcements, you'll eventually find it, I think. Could someone, one of the TAs, please post it again on the announcements? That would be great.
I will do it on the now.
Yes, anywhere. Okay. So we're waiting for group 1. Like the first group, group 6.
Group 6 is joining the Zoom, given the link difficulties.
Okay.
While Thomas is walking down, how was everyone's week?
All right, here, you take the microphone.
Yeah, awesome. How's everyone's code? Yeah. Yeah.
Open mic session.
Same.
Tell a joke.
So we are going to chat about what we think is a cool, but perhaps not the most ambitious we're going to see today, little package. So I came in, I do some work with MCMC codes for my research, and I was like, I want to do something with that. I've got this really nice, I've heard it called bespoke sort of wrapper for the MC package to do the stuff I need to do for my research. And my group's sort of like, let's try to come up with something that's a little more relevant to all of us. And actually, Thomas had the really good idea. If you'd like to share.
Yeah, so we want to do something with the MC package. Our package is called MC Wrapper, no W.
There you go.
Pause for laughter. So there's a bit of a learning curve when you want to fit something with MC, because you have to write up your own posterior, your own prior, your likelihood, blah, 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 blah. So what we've done is we have made a new learning curve. So we packaged all those inputs into this core class that lets you define your priors and stuff, and then you can do a fit really easily in Principal. So we have a little tutorial notebook that we're going to step through that just demonstrates some of this functionality.
Take it away. Yeah.
Okay. So you import MC Wrapper. The core class is called MC Wrapper with a W this time. And then we define a linear function.
Any kind of model function in theory should do.
Yeah, as long as it takes, some independent variable and returns some stuff and has some parameters, it should all work. But here we make a line, we add some noise to it, and then we tell our wrapper what the function, what the model actually is, what the data is, what the independent variable is. It can be 1 or 2D. What we call the parameters, what our first guess is for the values, what sort of priors we have, and I can go into more detail on this later, and then we can run MCMC, or we can run MC to sample it. And so we do that. It doesn't take long because it's a line, and then we can plot it up. Indeed, the line looks like the dots, so that's a win. And then we have visualizations to show us the chains here, and the corner plots using the corner library. So we've successfully wrapped their tutorial, essentially. We can do the same thing with a quadratic, and it works. And then, more ambitiously, we can do 2D stuff. So here, we're going to define a 2D Gaussian. And then we're going to fit it, and this one takes a little bit more time because more parameters and stuff. We can visualize the chains again, and then we can plot out the data. We've noised it up, the model, and the residuals. The residuals look like noise. Yippee. And then we also have a bunch of, how much time do I have?
1 minute.
Excellent. So we also have functionality for different priors. So by default, it's uniform, and you can input the bounds. You can also have Gaussian priors. You can also use gamma distributions. And we have functionality to sample those. So this is sampling different uniform priors with different bounds. So it works. And we do Gaussian priors. They look Gaussian. They're centered on different points. Or gamma distribution. So the exponential distribution is like one limit of the Gaussian distribution, and so that's what you see in...
You said Gaussian.
Oh, gamma. And so that's what distribution A is it's an exponential. You can also mix and match, which is cool. So we have a uniform in blue, a Gaussian in orange, and then an exponential gamma distribution in green. And so that is our package.
Just to grab this back really quickly to say, obviously, like all the packages, we're installable on pip. The sort of intended test case is if you have sort of a simple model you've been trying to fit for your research and you don't want to have to make this custom MC wrapper for an application, pop that and your data in there, give it a try, and feel free to reach out to us when inevitably it breaks.
Yay. All right, very nice. All right, group one, come on down.
Well, let's do this.
Take it away.
Hi, everybody. We made H2 STAM, which stands for the H2 Supersynthetic Spectrum Code Astro model. I'm Cole Meyer.
I'm Daniel Lopez.
I'm Cassandra Cruz.
I'm Dominik Makulski. Let's get into it.
First,
It's a
and it's an older me, but it checks out. So,
Okay, so our code here is based on a code that I had written previous to this workshop that is meant to simulate this really cool process in molecular clouds called H2 fluorescence. So the actual science behind this is not really important for this project. We have simply tidied it up, made it into a package, and sort of made it a little bit more sophisticated. When I first drafted it, I went from a reference paper and went straight through equation by equation. So we have sort of made it properly written. So first of all, pi, yeah. Very nice. And documentation.
Yes, so you saw earlier that we were pip installable, and we also have the documentation up online where you can see all of the functions that we have written, and we have already been able to hide all of the functions that you do not need to touch. It was a hassle trying to figure that out, but if you click through the functions, you'll see all their parameters and all their returns, and we're available online. Right next to that is, whoops. Do you want to do it instead?
Which part?
Transition to the next part.
Okay, I'm gonna pass this off. And as you could see in the documentation part, we are based on the one main class which performs basic calculation, so Boltzmann constant, etc. Yeah. And also this function is based on a lot of input parameters, such as all of those, plus minus 15 parameters, so we wanted it to be also reproducible. So we create a module at Chroma which creates config file for the user and also allows to dock the parameters after the use to have the current value which is used for the spectrum.
So thanks Dominic for that. So I will take you guys through a couple of things. The first is we use something introduced in, I believe, Python 3.7 called a data class. So one of the things that we've been talking about this week is writing like the init method for your class. And if you notice, for this lovely base count class, there's no init method. Well, there's no init method that we had to write because a data class is something that it puts in a lot of that basic functionality like an init method, like comparison methods and methods to convert the class instance to a string that you might want to write already, but this saves you the overhead of doing it and having to update it later. So you can provide initial values, types. It's nice. Yeah, and then now that we've gone through that, let's take a look at let me go to the tests. So
Collapse data.
Oh, it's in data. So, yeah.
Yeah, so apologies for the snafus, because no snafus ever happen with code ever. So, yeah, so well, Dominic's looking for that. Yeah. We made tests.
Very good. Next group is group 10. Come on down. All right, take it away, group 10.
I'm Julia Shepard.
I'm Max Croft. I'm Ellie Sepovich. The three of us are from UW-Madison, and we made this Python package called Orbeez, which Max will demonstrate right now.
So, as everyone else did, this is available on pip. We have a GitHub, we have documentation, and test stuff. So what Orbeez does is it takes any exoplanet system that's in the archive, and you can type in its name, and it will plot the orbits out and make a GIF out of it. This is probably going to take like 3 minutes, but in the meantime, you can see it working. It's making all these images one by one, and we get to look at them later, but I've got some that we ran already, so like Trappist 1, except my computer's lagging. Come on. There it is. What else do we have? You can do eccentric things, which was a pain. And oh, okay. So also everything is to scale. So I'll go back to Trappist, except for the planet sizes. So the star in the middle is colored based on the BP/RP from Gaia automatically. And then all of the orbits are to scale relative to the star's radius, and the planets are scaled up by like a factor of 25, but they are also to scale. So the use case for this is like, if you want to do a public talk, maybe. Doesn't do anything scientific. Let's see if the other one's done running. Nope. We're using, what's it called? Pillow? To make the GIFs, which is the like huge bottleneck of this, because it has to load in like all of these frames, and in order to make it not glitch out, we had to increase the DPI, otherwise the star starts flashing in the middle. But that makes it take longer, because they're higher resolution. Sure, I don't have it open.
Yeah, so we over-engineered the heck out of this thing, as you can see. This is our GitHub page. I spent a lot of time making it look pretty. There's some badges. We have docs and tests. Can you put one over there? That's our docs page. It has some installation instructions. They're very simple. I made a copy, a lot of Orbitize's syntax for this in particular. But yeah, it's just pip installable. Everything works except for that. I don't know why that one won't load. It did it on Wednesday.
Okay, well, this is almost done, hopefully.
It's almost done.
There'll be a new bar that says it's deleting all the images it generated afterwards.
I guess we can also talk about a little bit. We've got two sort of modes for this code. One is where you can define a system name that's on the exoplanet archive. The other one is the one you can build manually. You can do it either way. That's in our tutorial notebook that's on the GitHub. There it is.
Yeah, so
gorgeous.
This is like just the general function that actually does it. You can put in periods, semi-major axes, and planet radii. You can put in eccentricity if you want. And then if you just want to call it from the exoplanet archive, you just type in the name in this other function, and that function loads it all in and then calls this one. And that's basically the whole package. Thanks for listening.
Perfect, right on time. Group 16, come on down.
You're welcome. the plugin thing? This thing?
Yes.
Okay. Oh, my doctor's appointment.
Log into Zoom and share screen.
Oh, I'm in Zoom. Okay, cool. Okay. Hi, y'all. Yeah. So,
Use the mic.
okay, cool. So our package is called OBAF GKM. Let me pull it up on GitHub for y'all. So our package, its whole purpose is to look at stellar spectra, basically. So it's easiest to run in the command line. So we're just gonna open up a Python client and we're gonna import from OBAF GKM. The main function for our purposes is a prompt, so you're gonna import as P, you'll have imported it, and then you call the run function, and you have to select this temperature. So I don't know, what are we feeling for the start today? How hot is it? 3,000. Okay, I'm dwarf today.
This is the worst.
Well, are we doing a dwarf, or are we doing like a
No,
medium?
we're going 4.
Giant? Okay. Oh.
4.
Main sequence. Got it. Okay. Cool. And then what's the metallicity? Solar, supersolar, subsolar?
-2.
-2. Okay. Subsolar. And then we can tell it whether we want to save the plot or not. I'm not going to save it just for that. And then we get a spectra. So the top one is not normalized. The bottom one is normalized. And then we have a few prominent stellar lines there, the calcium HK lines, the sodium doublet, and then H alpha and H beta. This is basically all our package does. You can make spectra. We only have also spectral coverage.
Yeah, so basically these are just synthetic spectra that we generated using the Marx models and like the solar valve line list. But in theory, as long as you have a flux and a wavelength, you can generalize this spectra at any temperature range you want. So if you want to look at your synthetic spectra and interpolate really quickly, here you go.
But yeah, temperatures are limited. It maybe shouldn't be called OBAF GKM and maybe just like AF GKM because it doesn't go that far. But you know, we'll get there eventually. Look out for V1 out someday. Yeah.
Awesome. All right, let's keep going. Next group is, I already lost track where we are. Group 25.
Oh.
Okay, great.
Okay, here.
Hi, am I audible?
Yeah, we can hear you.
Yeah. Hi, so I'm Devesh, and unfortunately, Adiba and Daniel could not join me in presentation. So this is PGBGWPC. So it's a gravitational wave event plotter command line interface tool. So the basic motivation is that WASC has a lot of data, but at times it can be overwhelming for beginners to use tools like GWPy and PyCFC. So we'll make a lightweight command line tool to simplify the process. So how this works is you just pass the event name of the gravitational in the command line with some optional arguments, and it fetches the data from WASC, which is the Gravitational Wave Open Science Center, loads the event parameters, and then outputs the Q transform or the theoretical waveforms. So you can also just type GWTC help and it will give you the functionalities. And you can type the event name as shown here, and then it will give you this output and generate two plots, the Q transform plot and the theoretical waveform. You can vary the theoretical waveforms from whatever is available in PyCBC, which is a package used for gravitational wave data analysis. And you can compare the theoretical waveforms and the original data, which is on the left side of the panel. And then you can also see the list of events. You can just type GW or whatever prefix, it will search the event dictionary and output the event names which start with the prefix. And yeah, it has a modular design. and a command line interface. And the GitHub repo is this, and it is pip installable, and the documentation is posted on read the docs. And yeah, so we have some feature detections to make a user interface, multi-event and multi-detector plots, and some other analysis and population level interface. And yeah, that's it. Thank you.
There's many applause from the audience in case it doesn't come through the microphone. Awesome, thank you. Group 33, I think also remote? Group 33, this is Jorge and Nada.
Hello, I'm Jorge. Give me a sec to share my screen.
Yeah.
Can you see me? Sorry, I'm in a car in the middle of the Spanish countryside, so but connection is stable, so I should be able to present.
We hear you. Yeah.
Okay. So, my colleague Nada and me created a galaxy recognition pipeline. Basically, what we want to do with this project is be able to input some FITS file of a galaxy and determine its morphology. So whether it's spiral, elliptical, barred, bulge dominated, etc. So we use the Galaxy Zoo 1 dataset. And we built and trained a convolutional neural network model to determine whether to help determine whether these galaxies, the morphology of these galaxies, essentially. So we extracted the data, trained the CNN, and defined several classes that are explained here for the different types of galaxies. These are just some of the classes, but there are many more, which I'll show you afterwards. So these tests that we did, to test this project, we essentially created a pipeline that was able to produce dummy galaxies, which are FITS files, and then converted them into actual JPEG files and tested the whole photometry with them. Not photometry, sorry. The morphology. And this morphology could be useful, for example, as an example, to apply it for PSF photometry in Kovorik with a Sursic model. We haven't gone that far, but this is a potential use for it. So essentially, this test allows to define different spiral, elliptical, barred spiral, different morphologies for the galaxies. And then the dummy galaxy would be produced, it would be displayed, converted to JPEG, and we would feed it to the model, and then it would be the user's job to check whether the model would give the right answer or not. Essentially, now my colleague Nada will explain how the convolutional neural network works.
So basically, our model, CNN model, that is optimized for classification galaxy imager. So we do a classification for each galaxy. The CNN model will use this sample galaxy type as a label for supervised training. Each input is a galaxy image, and the output of the vertex which galaxy is it. So this is basically our model.
All right, thank you. Many applause from the audience in case it doesn't go to the mic. Okay, next up is group 18. Group 18, come on down.
Not in Zoom, sorry.
Okay, while he does that, we'll introduce the list of Andrew Adamo.
I'm Isabelle.
I'm Kayvon.
Hi, I'm Arnav.
This is Zoom link, right?
Okay. And while I'm not saying this up, so the motivation for this is that if you are, as well as I am, a total nerd, if you've ever wondered, is this star I'm looking at, has this shown up in some video game I played or book I've read or something like that? So we decided to build an application and a catalog to be able to look up the is this star show up in Halo or Star Trek or something like that? So now I have to wait for this.
Yeah, so sorry, we're getting to work and demonstrate, but the way it works is that we use AstroPy mainly to gather the data set of CBAD, where the user can input whatever object they would like to know, and it searches in the CBAD, and from there it searches through another data set that we created that Joe can talk a little bit more, and then it pretty much matches. So one crucial algorithm function is the angular separation, and we pretty much find all the angular separations compared to our data set, and from there find what's the minimum one.
So someone shout out the name of a star or something.
What's your favorite Messier object?
M67.
M67, sure.
Oh, I can read
So it says it's searched around M67, and the nearest object reference in sci-fi is about 5.5 degrees away. It's the Shvisha star, and here's some lore. So it's been referenced in Star Trek, the original series, and Deep Space Nine, and the context is about Epsilon Hydrae 7. And if we click on this button, which will show us the depiction on the full sky map. So in the red is our object, right?
Yeah,
and on white we have the name, and the closest sci-fi object is in yellow. It's a bit of an overlap because they're so close together.
It's better when they're not right on top of each other.
And if we click on view in Aladdin, so we get this cute little window which will take a lot of time to load. And there we go. And we like as you can see, we put it all together in a GUI, which was in its bare bones form until like yesterday, where we all sat together and made it look pretty. So we have another functionality where we can search it with ARIA and DEC coordinates. So for example, if I do like 2, 0, 0 and array, and then I don't know 70, 0 and 0. And if we search it, it will search around our coordinates, and it would still find the nearest sci-fi galaxy. So in this case, it is Groombridge 34, and it's appeared in Halo, with the Spartan 2. I have not played Halo in a long time, so I'm not sure. So if we look at the full sky plot, here you can see the arrow between what we have there. And I guess if I view this in Aladdin, let's see what comes up. Because I haven't tried this. Let's see. Alright, I blame the internet. Okay.
Thinking about it.
I just thinking about it. Anyway, let's see again.
It's alright.
Okay, it's the internet. Anyway, so the way we're doing it is we manually created this dataset which has about 80, which has about 80 sources where we have the RNA coordinates. Oops, I'm bad. And we have the source, and we have the object type and the load. So we hope to get more input, increases the data set, and for all the nerds out there. Thank you.
Very nice. Group 4 is next.
Hello to everyone on Zoom. This is Group 4. My name is Brooke Cotton. I'm a graduate student at the University of Michigan.
Hi everyone, I'm Jorge. I'm a grad student at Arizona State University.
And we have created a package called BDViz, which is for ground dwarf visualizer, although our package can actually work for anything you provide coordinates to.
Here's our logo. We also have we are installable via PyPy.
And then we have a lot of documentation, a little bit of documentation, as well as the testing. We have found everything to work, and I think learned a lot of lessons along the way about collaboration on GitHub.
So you may be wondering, how do I run BDViz? Well, you can pip install it, and we provide a Jupyter notebook for you on our GitHub, which you can download, called Run Examples. So once you do that, you can pull it up right here, and it runs in Jupyter, so we can load in these core functionalities. And let's say now you want to load in your scene where you would then begin plotting your brown dwarf exoplanet planetary mass object. We can do that right now. And it fully renders in Jupyter. And it outputs, first it wants to position you in the sun at 0, 0, 0. And let's say you want to move around a little bit. You can do that. Cool. And then let's say you want to plot an object on here when you initialize a brown dwarf object. So we can do that. And there we go. Plot it on there. Really nice. Let's say you wanted to add a second one. A little further out. The first one was at 5 parsecs. This one's at 17 parsecs. So the plot will adjust for you to plot it at a further distance. Now, I'm going to ask for audience participation. Does anybody have a favorite brown dwarf planetary mass object / exoplanet they'd like to know that they already have an RA and decan degrees for? Maybe? Oh, right here? Yeah, sure.
Gliese 229b, which is at RA of 92.6 and dec of negative 21.
Yeah, one more time.
My fault.
Yeah.
You need the coordinates right now?
Yeah, sure.
RA of 92.6 and dec of negative 21.9.
Let's call it 92 and 21. Now, what's the distance? Parsecs? Or light years times divided by 3?
I have the parallax. I don't have the 173 milliarcseconds. I can't do it.
Let's just say it's at 175. What's your favorite color?
Green.
Perfect. That's in Matplotlib. And then what was the name for it?
Gliese, I don't know if I'm saying that right. 229b.
229b.
I think another fun functionality that we have
Here we go.
is that we can plot based on temperature and
Look at that.
do a different gradient.
There he is. Yeah. Right there. Perfect. And
And you're adding functionality to create a Gaia query yourself, and then you'll be able to input that Gaia query and then plot all of the stars in 3D space as well.
two last things. Let's say you want to know the distance between two objects on here, like BD1 and BD2. You can calculate the angular separation between them. You can also calculate the physical separation between them in parsecs. And the final thing I wanted to say is, let's say I actually did not like Gliese 229b. Really quickly, I can remove it, and now it's gone. Thank you. Thanks, everyone.
Awesome job, group 4. Up next is group 21. Group 21.
So I'm Sydney.
And
sorry.
I'm Moreno.
And I'm Will. And the code we built is called Accessly. The idea behind this is that it's sort of a...
You guys have video.
Oh, okay, cool. The idea of this is that it's sort of a one-stop shop to just add in accessibility features into Matplotlib without having to go through each of your plt.plots and change the color, change the line style, whatever. You just put in a couple of arguments into this one function, and it does all the things for you magically. And so right now I have all of it commented out, all of the modules and everything that we've added in is commented out. So we'll run this, and we just have a plot. I've just plotted two cosine functions. And then, so the colorblind module is, we're still kind of working out which colors to modulate things to, because it's a bit finicky. But you would specify a certain type, and then it changes the colors in the back end. When you use plt.show, it changes what plt.show does so that it'll change the colors for you. Right now we have it kind of mapping to the plasma color scheme because that's a good color map for people with red-green color blindness. But what you'll see is that if we take out plt.show, then that goes away because the configure options that we've done are modifying plt.show.
And safe.
Oh, and savefig, yeah.
And PLT.savefig, so it works for both.
Yeah. A couple of the other options we've implemented are a module that puts an L and an R label on the left and right. This was a very simple kind of first test case, but the really cool thing about all of the way that we've structured this is that it's entirely modular. It's entirely modular such that you'd never have to change the core file or the config file. You just make a new Python file for each of the specific accessibility features that you want to add, and now you have a new functionality. And so if we look in the directory structure, we have, this is the core directory for the accessly package. And then if you go in here, you just have this init, config, and core. You never have to touch those. If you want to add your own accessibility option, you just add in a Python file to this folder and format it in such a way that it can communicate with the core file, and then you can have a new accessibility option. So another one is to change the font so that it's more legible for people with dyslexia. And you can, I guess it's hard to see because the font size is kind of small, but you can, one of the arguments in that function is that you can change the font size. It will be. It will be. I apologize. But you can also change, if you have a specific font that you want to use, the font name is an argument for sure to that one. So it defaults to one that's generally usually good for people with dyslexia, but different people have different preferences, and so you can just add in the font you want. We have one that adds alt text, and so it just adds a little bit of text about what you're doing. You add a description and it puts it at the bottom. This is a little finicky if you're running it on a Py file. It's a little better with a Python notebook, but we'll figure that out. And it also yells at you if you haven't added anything into the metadata. plt.show doesn't have a metadata argument, so it's always going to yell at you if you do plt.show. But with savefig, there is a metadata argument, so it looks at the metadata argument, sees there's a description, and if there's not, it says, hey, you said you were going to do alt text for this one and you didn't add it. And then finally, we have one that does different line styles, and it has things that it automatically cycles through. So you don't have to go into each plt.plot and add in which line style you want. You just say line styles, types, diff, and then it'll do different line styles. And I think there's like 6, is that right? 14. 14, oh, 14, look at us.
It's not very functional at that point, but.
Yeah, that it'll cycle through. And yeah, so that's what we have now, but you can add whatever you want. So whatever fits your use case, you just make a Python file, add it to the folder, and there you go.
It was a great project because we learned all about monkey patching this week.
Yes.
Ooh.
Thank you.
Group 2.
Thanks. Hi everyone, my name is Miranda, and I'm Gopika, and we are presenting Dusty Disk. So the motivation is that a couple of months ago, I realized that I love to work in planet formation, and it was a great shift from a different field. So when I was going through a couple of reviews, I realized that we need both dust and gas for planet formation. And when there's a local pressure maxima in gas, there the dust will be trapped. So I was like, maybe we can visualize this. If we have a bump in the gas pressure, let's see if the density of the dust is like, peaked over like near the maxima or not. So,
so this is our GitHub page. We have a little Code Astro badge, and then we also have a documentation website. If you click on it. So that's what that looks like. And then you can also pip install Dusty Disk version 1.0. So we're going to walk you through an example tutorial that we have. How do I move this? Okay, so the way that our example works is this cell, hopefully we can do this live, you import all of the functions in Dusty Disk, and then what it does is take in information about your disk system. So that's what this cell does here. The things that you need to assign are the radius profile and binning, the gas density in your disk, and your gas temperature, as well as like the mass of the central star. And then here we call the first function in our package that initializes the system. We call it toy grid, and these are all our inputs. Do you want to?
So like you can specify the things you want to plot. So like in this, you can see that you have gas density and gas pressure, and you can definitely see a bump in the gas pressure. And we have included different grain sizes. So you can see that we have like V drift, which is like the drift velocity of the dust. And you can see that like for different grain sizes, the velocity is different. So which I found like pretty cool. Like so if you force the Stokes parameter to be like a constant or something, you can definitely see that the V drift is V drift will be the maximum for the particles with Stokes parameter around 1. So like if you're in planar formation, you would know that like the V drift properly like depends on the Stokes parameter, and when the Stokes parameter is like 1, around 1, then V drift would be like maximum for those particles. So you can definitely see that in V drift. And this is the dust density, and you can see that it kind of peaks around the pressure maxima. And so this is like
so just to like remind everyone, so you just input in density and temperature, and then we also have a function that does like a cool 2D representation assuming spherical symmetry. So this is like where the dust would be settling in the input system that you give to Dusty Disk. How are we on time? Do we?
45 seconds.
Yeah, so like you can see different grain sizes here. So yeah.
And then we have another example with 2 bumps. Maybe we can do this. So you can do the same thing, but now there's like 2 bumps in density, and then some more pretty pictures.
Yeah, now, and we have like a test file, like where you can test this code. It's basically like just forcing the pressure gradient to be like a constant. So the gradient would be 0, so there's no bump. The V, like you can see that the V drift would be 0 because like the V drift depends on pressure gradient, like it's proportional, so it would be 0. So yeah, that's the test function.
Thank you.
Thank you.
Very nice. Group 26 is next.
Hello, my name is Sam.
And I'm Shafrael.
And we are presenting the LC Enhance package. LC Enhance is for light curve enhancing, and it's a pretty simple tool that is useful for visualizing light curves of transiting exoplanets. The main functionality is there are two options. You have two different classes here. You have a theoretical light curve and you have a exoplanet light curve, and that shows up, if I can get rid of that, here, where there are two main options. You can either decide to put directly in the transit parameters that you want to visualize, such as depth or duration, or you can put in the parameters of actual stars and exoplanets that you'd like to see. So in this case, there's HD 209458b. From this, you can also then customize how you want the light curve to actually be plotted. So you can decide, oh, I want to do multiple periods of this, hence 3 periods. Or you could phase fold over it, where now you're left with one phase folded plot of 3 transits over it. There are also some options where you can go in and modify how you actually want the shape of the transit to happen. Right now it's set to the trapezoidal, so there's just a simple line going on either side. It's pretty easy to set it to either a curve or just a straight drop.
Yeah, so if you wanna maybe teach exoplanets, maybe teach transits to for any outreach demo, or maybe provide some synthetic data sets for algorithmic testing, this could be a very good use case for you. But if you wanna maybe add more functionalities in the future, so fingers crossed.
Yeah, and this is installable with pip install, and it's also on GitHub. There's also a test suite that just goes through and tests a few of the basic functions, mainly with making sure that inputted data actually outputs what you'd expect. And these two systems here are actual exoplanets that have transits measured, and this is somewhat accurate. The other thing that I also forgot you could mention, you can zoom in, so you can actually see what the transit looks like up close, even if you're plotting a really small transit. Thank you.
Awesome job. All right, next up we have group 12, which should be remote.
Yes, hi. Just gonna share my screen here. My name is Claire. We're presenting from UCI, the UCI local hub, and we put together a package called Habitax.
Habitax is a pipeline built for those who are interested in studying exoplanet properties in the habitable zone by querying the NASA exoplanet archive. The user can input specific stellar and properties to evaluate whether a given exoplanet falls within the conservative or optimistic zones. And the output includes a mass radius relation plots and additional plots of the habitable zone and implanted around its whole star for a given system, which will be shown in the following. But the main idea of the pipeline is to allow the user to perform the target selection for survey planning with specific parameters, and the code also outputs what type of planet the target is, which will be shown in the following slide.
So here are some examples of cuts you can make on the exoplanet archive data. So you can add columns to the default ones that we already have. You can do cuts on declination or the effective temperature of the star, and you can specify that you want the mass and radius of the planet to both be populated and not null. And so here, down below that, you can see the columns that we calculate as part of our package. So we calculate the planet type, whether it's a rocky planet, a potential water planet, or a gaseous planet. We calculate the optimistic and conservative habitable zones, and then return a Boolean for whether the planet is in the optimistic habitable zone or in the conservative habitable zone as well.
This is a mass radius relation for all of the planets in the exoplanet archive that are in the optimistic habitable zone. We're using the definitions from Koparapu et al. 2013 for optimistic and conservative habitable zones. So this is without performing any cuts on the planets that you're querying. This is just everything that shows up in the optimistic habitable zone. And similarly, the conservative habitable zone includes everything that was in the optimistic habitable zone. Or sorry, everything that is in the conservative habitable zone is also in the optimistic habitable zone, but not the other way. And this is colored by the host star effective temperature. So you can relate some of the planet properties and host star properties here as a visualization of your sample that you're looking at.
All right, so one of the cool features we have with Habitex is that we can plot where the habitable zones, so both conservative and optimistic, is for a given star. So here we have two examples, one where if you input a planet name, you can also plot where the orbit is going to be with respect to the habitable zones, the two ranges. So we have two examples here, one where the orbit lies within the habitable zone and one where it doesn't. So you can compare through this feature that we have with Habitex. And next slide. Perfect. We also, so if you don't input a planet name and you have a system with multiple planets, we can also plot all the planets around that star. So for example, here with TRAPPIST-1, with 7 planets, you can visualize with Habitex where the orbit lies with respect to both the optimistic and conservative habitable zone. And yeah, one thing that we learned from this workshop is that we can put vintage memes. So here are some for you guys to enjoy. There's more in the next slide too. Yeah.
Very nice.
Great job, guys. Proud of you.
Awesome job, Group 12. Group 27, also remote.
Yeah, let me share my screen. So our package is called Planet Tapper. And the main use of Planet Tapper, let's cover, before how Planet Tapper works, let's cover the niche that it's filling. So a lot of times when you're working in exoplanet detection, you're trying to make some, trying to discover transiting planets and stuff, you need a lot of planetary and stellar parameters. And it can be really inconvenient to have to search them up online and use the NASA Exoplanet Archive and then hard code them into variables inside of your code. So Planet Tapper utilizes the table access protocol that NASA has set up, and it uses the search by name and search by parameters functions that we've generated to create these planet classes and star objects that contain all the relevant attributes within it. So now, instead of having to hard code these into variables, the user has access to an object that contains all these parameters for them, allowing them to do computations much quicker. And here, I'll demo how it works. Oh, I have to share my other screen now. Sorry, guys.
Yeah, so we just made it easier to get all the info.
Yeah.
With one simple request.
Yeah, so here's our end-to-end testing that we set up. Click run on this. So while this is running, I'll let you guys know what's happening. Basically, I have a parameter search that's running where it's looking for all planets between 5 and 15 Jupiter masses, and it's taking them and it's iterating through them and plotting them. So here you can see all the planets that it was able to find, and then in a second here, the plot should load up. It's just a little slow right now, but this makes it a lot easier because instead of having to hard code all of these mass Jupiters into somewhere in your code, they're just contained within these planet objects, and you're allowed to just iterate through them in a for loop. So that makes that really nice. For some reason, this is not showing. But I want you to imagine a plot that looks really nice now and it has a bunch of planets on it and has the mass Jupiters right there, and it's like a really nice line. But I don't know why it's not loading up.
It is a very beautiful plot. I just want to make that clear.
Oh, there we go.
So
There we
whatever
go.
plot you're imagining,
I got it.
beautiful. It looks great.
There we go. Look at that. And I think it actually happened very quickly. I was just too stupid to share my screen. That's my bad. But look at that. It just all generated in a second when usually the user would have to hard code these variables and you can't even really utilize a for loop unless you set up the array yourself. Whereas we had the array of planets generated for the user in like a second. So yeah, that's really it. Thank you for watching our presentation.
Thank you for coming.
Well done.
All right, thanks again. And then group 24 is next. Back in the room. We have to switch microphones. You talked so much, the last one ran out of batteries.
Actually, I'll give you mine.
Hi everyone, I am Tara. I'm Nico.
And Chifong here. I just realized our name is like so ambitious, like saying Astro view, but actually we only do the asteroid view thing. But we took that name already, so you can't really do that on PIP now. So our package actually does things like help you view what the asteroid look like at a given time. And it emerges from one of the research I was doing because asteroids are not like the other type of objects. They're like moving all around. So sometimes if you don't get the data, you don't actually know what's going on, or at least for me. Like I'm not sure if it's because the data is not going well, or actually we can't actually see that asteroid at that given time. So I was thinking maybe just having this package of directly showing you where the asteroid is, how is the relative positions of like sun, earth, and even moon, because those are major like light contaminators, and what they look like, and especially like what does it look like when you're at the position of that telescope at that time. So this is our package. Now it's like on PEEP, and also here's some documentations of ours, and Tara will go through some details of that.
Yep, so in the GitHub you can find these example notebooks with all of our functionalities, how to import the package and the main class. And so with this package you can give the name of the asteroid and the time, and then you can have a 3D view. This plot is heliocentric, so here you can have the sun, the earth, and then the object. And we also have a 2D view from the observatory, in this case it's from Kidd Peak, and then you have the object, and yeah, here we have the same object but from the southern hemisphere. And a fun example, for example, is this near-Earth object. You can see the orbit and how close it gets to Earth. And here our local sky. We can see the sun and then different objects here. And here you can have some resources from where you can find the name of the asteroids and the code for the observatory. And yeah, hopefully this is something that's fun to play around. Thank you.
Great, thank you. And then we have group 22.
Where is it? Oh, sorry, I'm loud, so we'll see how this microphone works for me. Hi all. I'm gonna connect to Zoom real quickly. No, I am on Zoom. I just need to share my screen.
Introductions while you.
Yes.
Okay, so while Ed connects, we'll do introductions. Hi y'all, I'm Fofi. I'm part of the UCI, but I decided to go to Chicago because it's better.
I'm Emma.
Hi, I'm Ed, and today we're going to be presenting you guys Galinda. Galinda is going to be a tool that is used to quickly plot any of your simulation data. Because I don't know about you guys, but sometimes you're running simulations and you want to make a movie, and then you did it 4 years ago, and you forgot everything about it. So this is just a way where you can more streamline the process of making that simulation data nice and available. So all that it really requires is just a folder. It does require that all the files need to be in HDF5 at this current moment because that's kind of standard for any simulation data. And then one parameter that you want to be plotting with it. So all you really need to do is you're going to do from Galinda, import bubble. She came down in a bubble dog. And then you are going to just run gal.bubble, and then we can run gal.animate. And then we get this nice little image that shows up. But if you just want to see it in terminal, all you need to do is say that object.ani. And then in about 20 seconds, it will be showing up. While we're waiting, we also have the ability to just save it and just very easily do that. Because again, sometimes matplotlib code is really annoying. And sometimes you just don't want to have to write another for loop, and you'd rather just put in a folder and see the output. Yeah, so that's Galinda.
Very nice. All right. And final group 22.
Hi everyone, I'm Greg.
I'm Doug, nice to meet you.
And I'm going to take my embarrassing fumbling of basic technology as indication I should apply for faculty positions. So we have been working this week on the Alderon pipeline, which is a transit fitting pipeline for automated light curve detrending exoplanet recovery and analysis of autocorrelated noise. What it does is it takes in raw light curves from NASA and then processes them through all the way until the end to get inferences of transit posteriors. So we are pip installable, and the goal, which we're very close to getting to, is to be able to, with a single line from the console, just fully process any light curve from any major NASA mission. It works on Kepler data right now. Sheila's been working getting up on K2, and Devout has been working on getting the pipeline to automatically query the mass servers so that if you haven't pre-downloaded the data, you can just say, process this target, get this target, and it'll download the data for you. And so from the console, you just pass what mission you want, what target you want, and then you'll set up a config file with some instructions on how to actually run the data. So what does it do? Well, before we get there, I'll just give a plug. If you want to contribute, we have a number of issues. There's a lot of work left to be done, but we are pip installable. We've got the docs up and running. Doc strings are not fully populated yet, but they're getting there. So as the pipeline runs through, it creates a number of quick look plots. So this is the raw data that gets run in. It indicates where all the transiting planets are. After some processing, the light curve looks nice and flat. It's fully detrended using some Gaussian processes implemented in Celerite. And then it will fit individually each of the individual transit times for however many transits there are in the system. Here are just a few examples. And you get a model of what the transit timing variations look like with automatic outlier rejection and a smooth transit model. And then that feeds that into a nested sampler with Dynasty, and it very quickly will get you posterior inferences for all of the planets in the system. This happens to be a 3-planet system, so 3 planets. It will produce corner plots for you, and you get all the information. And then, of course, our most important quick look plot, my research assistant, Ruby. Yeah, that is it in a nutshell.
Awesome. That was a lot of cool packages. I feel like we've seen quite a range. Every year, we're always impressed at what you guys manage to come up with in the span of actually just 3 days, basically. So it's been really awesome work from all y'all. We should take a break before we do the next thing. We've been going for like 2 hours straight. Let's take a 5-minute break. Yeah, well, it's a 5-minute break. We'll return at 23 after the hour, and then you're gonna pair up with someone else, another group, and try to install and run their package and see how it goes. All right, so we'll return in 5 minutes. In 5 minutes at 23 after the hour. All right, everyone. Let's get back together. So the next step, we're just I think seeing someone else who doesn't know your package try to install and use your package like first person is a very enlightening experience. So that's what we're gonna do next. So for the next 22-ish minutes until 50 minutes after the hour, we're gonna for the folks in person, try to find another group, pair up in person with another group and try to install their package. For the folks on Zoom, we're opening up a few breakup rooms, and we've tried to pair you all in breakup rooms. So go to the breakup room that we say in the chats to you to go to. We'll be doing that for the next 20-ish minutes. So give it a shot. Show each other your GitHub links, your documentation, and let them try it and see what chaos happens on the screen as they try to do that. So let's give it a shot.
All right, everyone. I assume that went extremely smoothly. Nobody ran into any bugs. Everybody pip installed correctly, and you can all go home happy. In case that's not the case, it's okay. It happens to all of us. Hopefully it was a good learning experience to actually watch someone try to pip install your package. I just want to do a couple of quick closing remarks before we send you on your way. First, I want to remind you about all the topics we covered. So day 1, we talked about development environments, programming paradigms, functional versus object-oriented. We went through Git basics, we did Git flow, and then in the afternoon, we had best practices for NumPy and Pandas, Matplotlib, and intro to JAX. On day 2, we didn't actually do Git flow on day 1. We did Git flow on day 2. We also did Jason's Git by hand. We talked about debugging with VS Code. And then in the afternoon, we talked about parallel programming in AstroPy. On day 3, we took you through the process of releasing your code on GitHub and PyPy, also doc strings and Sphinx. And then on day 4, we did software testing, anti-discriminatory practices, and in the afternoon, optionally profiling your code. So hopefully you are now able to use the language of software development. As a reminder, we've got this vocabulary list that'll stay up. We add to it every year. It's become a really nice resource. I saw all of you develop and release an open source astronomy package. Again, it's so amazing what everyone's able to do in this week. And write code that follows best practices of software development. One quick note on that last one is that you can't actually learn to write code that follows every best practice in a week. And nobody's perfect. We're all constantly improving. So also keep in mind that the best practices we presented are suggestions and we don't always follow them exactly. So don't think of this as you must do this. It's bad if you don't do this. And also we're not perfect coders. So please continue to give us feedback and continue to keep that in mind in your own coding. We would also really love for you to stay in touch. Discord is going to stay up forever. It's really fun. You'll get to, when all the new attendees come in next year, you'll be like, I remember when I was a new attendee in Code Astro. And the Piazza link will also stay up forever. So every once in a while, someone will post something like a new question in the Piazza. You're welcome to do that. Or you're also welcome to reach out to both of us on Discord or email or whatever. Also, the materials on GitHub will stay up forever. We'll probably keep editing them for next year. But now you know how to version control, so you can always go back and find exactly the version that you saw in Code Astro if you want. And we've also posted all the answer keys for all the activities in the announcements channel in the Discord if you want to compare to our solutions. In general, we'd love to stay in touch. So please reach out. Our email's on the intro slides for both me and Jason and all of the TAs. I want to take 5 minutes to ask you to fill out this feedback form. This is really important for us this year. We don't have funding for next year, and we really need your help to get funding. And the best way that we can do that is by showing that Code Astro works and that it's actually had an impact. So please fill out the feedback form. In the future, if something you do benefits from Code Astro, please let us know. I'm gonna give you 5 minutes to get started on that now. Yep, question?
Will the YouTube video stay up?
The question is, will the YouTube videos stay up? Yeah, the YouTube videos will stay up forever. We're going to edit the YouTube videos and put the edited versions online as well, so that there's not hour-long pauses when everyone's in breakout rooms. But in the meantime, the raw recordings will also be up. The links to all of the recordings are also in the announcements channel. Mm-hmm. No, yeah, good question. So this is not the daily feedback form. This is a different feedback form. So
I posted both on Discord.
Oh, excellent. Thank you. Jason posted both on Discord for those that didn't hear. Yes, the question was, how do we like to have Code Astro acknowledged in publications? We would, whatever you want. I don't know, do we have a preference?
Okay. We're a little behind on this. We don't have a how to attribute Code Astro, but it would be really good if in the future if you do anything that benefits from Code Astro as a piece of code, to put it also in the Code Astro project database that we send out. So not just the projects that you make here, but future projects that for your own research. I think that would help us the most, just so we can have a collection of various papers and publications that benefit from Code Astro.
Yeah, and that's this database form. So please bookmark it if you want. All right, in Code Astro tradition, I know that wasn't enough time to complete the group activity, but hopefully you feel like you started and you can continue later. So last thing I want to do is just a couple of thank yous. First, I want to thank all of our absolutely incredible TAs, without whom this workshop absolutely would not have happened. We also want to acknowledge funding from the Isaac Simons Foundation, from NSF. I also want to give a huge thank you to Jason, who ran this workshop amazingly without me here earlier this week, and who I'm super grateful to have as a friend and a mentor. And also thank you to William and Janet, who were working incredibly hard behind the scenes. William was here making sure all of the food was set up, making sure that all of the logistics, all of the name tags were set up. Janet for booking everybody's flights and dealing with reimbursements and everything, and dealing with all my idiotic questions about what is able to be reimbursed and not. And a huge thank you to the staff at the Holiday Inn also for keeping us all housed. And most importantly, thank you so much for being here. I'm so proud of the community that has come together over the last couple of years in Code Astro. I'm really honored to be a part of it, and I'm really grateful for all of you for your work, but your inclusivity and your willingness to make astronomy in the world a better place. We've been doing this for a long time, which is really cool. In 2020, we had 30 people on Zoom, and now we get over 200 applications, and we had 70 people in person this year. This was the biggest year ever in person. We had local hubs for the first time this year. The program has grown a lot, and I'm really amazed and really grateful to be a part of it. So I'm really happy that you're all here. It's very cool. All right, that's a wrap. Thanks, everyone. Bye.
Thank you.
Thanks, everyone online.
Thanks for sticking
Thank
around.
you.
Thank you,
Thank you. Have a good one.
Thanks, Jason. Thanks,
Sarah and
Sarah.
Jason, for organizing this
Thank
workshop.
you. Bye, everyone.
Bye-bye.
I'm too weak for this right now. Too many emotions.